Sir is a fellow of Institution of Engineers, Kolkata, life member of Systems Society of India, and member of Automatic Control and Dynamic Optimization Society. Sir is a member of Board of Studies of Department of Electrical Engineering, Usmania University, Hyderabad, and JNTU, Hyderabad, Kakinada, and Anantapur. He is a member of the Doctoral Committee at Veluru Institute of Technology, Velur. Sir reviewed two books published by Tata MC Grew Hill Publication Company, New Delhi, on neural networks. Sir areas of interest are power system operation and control, power system stability and security, neural networks, deep learning, machine learning, and fuzzy logic applications, etc. Thank you, sir. Thank you.
Yeah, thank you very much, Anil, for giving me this opportunity. And as well as I will thank the management of your institute for giving me this opportunity in this ATAL program on artificial intelligence applications to renewable energy sources. Are you able to see the screen? But share is not, it is disabled this link. Share. Huh? No. Where I have to click? Present no, yeah, there only I click this one. Ah. Now my presentation. Huh? That is why sharing should come, na? Sharing. Present now, I click. But share is disabled. That no, the button is not active. Cancel is active. I don't know. That is. Okay, shall I share? Huh? Okay. Hello? ఒక ఎంటైర్ స్క్రీన్ చేస్తాను. Is it coming? Your screen is still visible to others. Click to resume presenting or stop screen sharing అంటారు. Is it visible? No. చెప్పండి. Stop. Okay. Is it visible now? Okay, fine. దీని స్లైడ్ షోలోకి వెళ్ళండి. స్లైడ్ షో. స్లైడ్ షో F5. వచ్చిందా? Slide. Okay. Hello, Anil. Are you able to listen? Okay. And you will PPT, you will control. Okay. Next page. Yeah. Next PPT వచ్చేయండి. నేను చెప్తాను. స్టేజ్ PPT చేంజ్ చేయండి. హలో. PPT. Okay. Okay. Sorry for the inconvenience. It is first of all, the title of the Atal FDP is there is AI applications to renewable energy sources. Then first of all, I will talk about a basic discussions about the total installed capacity in India and what are the blackouts in 2012 in northern India. To blackout took place. What are the reasons and all that? Then I will switch over to the some of the techniques. Yeah. Next. In this one, as you will see, in this Indian power sector, because every day, because of the renewable sources, the total installed capacity goes on increasing. Because therefore, today, what is that? Today is the 9th December. The installed capacity is more than what I am showing here. What I am showing is a nearly 443 gigawatts. As on today, we are talking, good old days we used to talk about in megawatts, but as on today, we are talking about gigawatts. Therefore, the figure which I am giving for nearly 443 gigawatts is on 30th April 2024. Okay, next. Okay, in this one, the entire India is divided into 5 regions. One is the northern region, another one is the western region, southern region, eastern region, and northeastern region. And we're having islands, that is Andaman, Nicobar, and Lakshadweep together. Suppose if you see as on 30th April 2024, that is northern region is consisting of 123.627 gigawatts, and western region is 146.81 gigawatts, whereas southern region it is having 129.53 gigawatts, eastern region 35.544 gigawatts, northern region is 5.17 gigawatts, and islands, okay, very small amount, that is 0.059 gigawatts. Okay, next. Okay, in this one, in the Indian power sector, when we are having as on 30th April 2024, 440 gigawatts, out of this one, renewable sources is around wind is total renewable is 144.751 gigawatts. Out of this, wind is 46.161 gigawatts, solar is 82, okay, and biopower, that is biomass, waste, etc. It comes that is biomass is around 10.355 gigawatts, whereas waste energy is 0.591 gigawatts, and small hydro is 5.005. Therefore, out of total installed capacity as on 30th April 2024, it is southern region, that is total installed capacity in southern region is 129.538 gigawatts. Southern region means it consisting of several states: Andhra Pradesh, Telangana, Karnataka, Kerala, Tamil Nadu, Pondicherry, and Neyveli Lignite Corporation (NLC). Therefore, out of these 6 regions, we will call southern region. Suppose each state will call state grid. Suppose if you take any state, Andhra Pradesh or Telangana, for example, Telangana, we are in Telangana. Therefore, every state will have its state grid. Therefore, suppose for example, in the Telangana state, we are having thermal, hydro, nuclear, at a particular point, we will call as a state grid. Therefore, in this Telangana, on 30th April 2024 is 19.519 gigawatts. Therefore, the entire power in a particular state. That is, we will have the energy management systems I will talk about. Therefore, each state. Therefore, all the southern states, like what I was mentioned, that is Telangana, Andhra Pradesh, Tamil Nadu, Kerala, Pondicherry, and Karnataka, all put together, we will call it regional grid, the southern region. Like that, we will talk about northern region, etc. Therefore, just like the state grid, which is there, any state, their capital cities, we will have the load dispatch center or control center. Therefore, by sitting at load dispatch center, we get several data. Therefore, we can conduct, by SCADA system is there, supervisory control and data acquisition system. In the supervisory control, it is nothing but a real remote control, supervisory control. Therefore, sitting at a load dispatch center at Hyderabad, I can control nearby states, our nearby districts like Warangal or Karimnagar or Ramagundam. We can switch on or switch off the circuit breakers, or we can switch off or switch on the capacitors, shunt capacitors which are connected. Okay, we can do remotely control. And by using RTOs, we'll get the data. Therefore, we'll call supervisory control system is heart of the load dispatch center. That is why we'll call supervisory control and data acquisition system is the heart of the energy management system. Therefore, whenever we are having several ways of generations, that is generally coal is 58%, hydro 18%, renewable sources some 12%. It is the old data. With gas 9%, diesel 1%, 2% overall country. Next. Therefore, if you see the projection, that is 2021-22, we want to generate 425 gigawatts. Therefore, instead of 21-22, at least in 24, we are achieving this 425 gigawatts. But in 26-27, we should achieve 575 gigawatts. And 31-32, our projection is 778 gigawatts. Next. Therefore, in this one, if you see, as I mentioned, in the installed capacity as an 30th for 2024 is if it is 442 gigawatts, and out of these renewable sources, of 144.75 gigawatts. This is the Indian installed capacity. If you see our counterpart, the China, as because this is I took from the Google because most of the time it is approximately in 2023 itself. Okay, their power is installed capacity is 2,920 gigawatts in China, whereas the renewable sources include 900 gigawatts. Therefore, just it is for comparison point of view. Therefore, the renewable sources 900 gigawatts, Indian renewable sources is 144.75 gigawatts. Okay, next. Next. Hello? Hello? Yeah. Therefore, in this one, in this July 30th and 31st in 2012, in northern India took some blackouts or took place. Therefore, on 30th and 31st, both the days. Therefore, the reason was to black out. Several reasons will be there. One of the reason was at the time that is low frequency. Therefore, good olden days we used to make use of frequency as well as voltage plus or minus 5%. But because of blackout in 2012, we are keeping my voltage is still plus or minus 5%, but my frequency is not plus or minus 5%. It is lower frequency is 49.5 and upper frequency is 50.2. Therefore, electricity boards they are maintaining strict discipline of the frequency. Therefore, in this one to maintain the frequency, okay, because everything in power system will have the real power and reactive power. Therefore, whenever we are having the real power balance, that is real power total generation equal demand plus losses, it is there. My frequency is approximately constant. That is 50 hertz you will get. If my generation is more during night time, more than the demand plus losses, then my frequency increases. Generation is less than the demand plus losses, then frequency decreases. Therefore, as in today, our frequency limits are 49.5 minimum and 50.2 is the highest. That is maximum. Okay, within that one, we should. Therefore, anything we want to maintain within that limits, we should take care of real power. Next. Therefore, in this one, there are some surplus states are there, deficiency states are there in India. Therefore, the surplus states, that is excess power, they are generating more than their demand. Himachal Pradesh, Sikkim, Tripura, Gujarat, Delhi, Dadra, and Nagar Haveli, the surplus states. Next. And in this one, if you see some targets, that is we're having this is also some old data only. Out of this one, first highest consumption of the electricity is the United States, next China, Japan, Russia. Then we are coming the fifth state in India. I think as on today, because of our generation, solar, renewable sources, etc., we might have crossed Russia also. Next. Therefore, with respect to the region's point of view, the India is divided into 5 regions. As I mentioned, the southern region, western region, northern region, as well as the eastern region and northeastern region. Back. Therefore, in this one, if you see the southern region as several states, that is what we're having, Andhra Pradesh, Karnataka, Tamil Nadu, Kerala, etc. Therefore, the control center for southern region is at Bangalore. And if you see the southern region, it is a high load. It is 40% is agricultural load out of this one. And monsoon dependent hydro. When good monsoons are there, then only hydro station will be there. Otherwise, the hydro stations will not be in working condition. And if you see this northern region, that is Himalayas and all that, it is a deficient region and snow-fed run-of-the-river hydro, that is, it is a Himalayas snow-fed and Ganges will be there. Therefore, throughout the 365, Ganges will flow. Therefore, run-of-the-river hydro, therefore small hydro stations also will start working there. High weather-sensitive loads. Loads are weather-sensitive because fog, weather conditions are very critical. Therefore, the loads are weather sensitive. And one more thing is that adverse weather conditions, that is fog, dust, etc. And if you see the western region, it is industrial load and agricultural load will be there. And eastern region, that is low load is very less, but high coal reserves and pithead based load plants. That is wherever the coal reserves are there, there itself we are having the thermal stations. And one more thing is that we are having northeastern region. In this northeastern, where load is very less and high hydro potential. Because of high hydro potential, we can generate lot of power. Okay, but load is very less. But thing is that when generation is high, load is less. The remaining generation they can send to the some other states. But the thing is that evacuation problem. Why there is evacuation problem? If you see this red chicken neck is there. What is the chicken neck? The chicken neck is nothing but a small area because we are having other countries. Therefore, the area between this northeastern region to other part to install the towers, etc., the space is not sufficient. That is why there is an evacuation problem is there. But next, if we see the load dispatch centers, that is how it starts. Suppose we are having some RTUs. Suppose if we take a generating a state, we will have at a particular substations and generating station, we will keep RTU. What is RTU? Remote terminal unit. Therefore, we are having a remote terminal unit. They will capture the data, real power, reactive power, okay, and frequency, etc. From there, from the load dispatch center, they will convert the data which is coming analog to digital. Then it will go to the subload dispatch center. Okay, that is subload means that is some small districts, etc., and all that. Subload dispatch center. From subload dispatch center, it will go to the state load dispatch center. That is what I was mentioning. State grid. Okay, state load dispatch center and our regional load dispatch center. Suppose if it is southern region, we are having it Bangalore. Suppose northern region at Delhi. Okay, then western region we are having at Bombay, like that. Therefore, this all regionally we are having 5 regions are there. All southern state load dispatch center to the regional load dispatch center. From there, it is going to the national load dispatch center. Therefore, this is our structure. Therefore, we will cover for this energy management systems, or we can call load dispatch center. The heart of this one is the SCADA system. Next. Therefore, we are talking from the beginning several regions. That is, if you see the Indian power sector, you will have the northern region electricity board. You will have the what are the states will come into picture is Delhi, Rajasthan, Himachal Pradesh, okay, Punjab, Haryana, Jammu Kashmir, Uttar Pradesh, etc. Suppose if you take this eastern region, Bihar and Orissa, Sikkim, West Bengal, and northeastern regional electricity board will consist of Assam, northeastern Assam, Tripura, Meghalaya, Manipur, Mizoram, Nagaland, Arunachal Pradesh, etc. As I mentioned, southern region, Kerala, Karnataka, Tamil Nadu, Andhra Pradesh, we can add Telangana and Pondicherry also. And western region is the Goa, Gujarat, Maharashtra, Madhya Pradesh. Therefore, these are 5 regions are there. Therefore, each region will have the, apart from the state control centers, we will have the regional control centers also. Therefore, most of the time, what they will do is that the regional control center also will have the SCADA system will be there. They will maintain frequency, voltage, etc. constant. And one more thing is that in this load dispatch centers, either in the state load dispatch center or regional load dispatch center, they will do several functions. What functions they will do? Online load. First, they will do state estimation and security analysis. Okay, economic load dispatch, security. Okay, AGC, automatic generation control, etc. They will do. Therefore, and one more thing is that after doing all these things, they will do some control action also. Suppose if you take, whenever we are having, if you take any region, okay, either take northern region, eastern region, western region, anything, each load dispatch center, we will do these functions. For example, load flow analysis. Suppose if you do entire 5 states or 6 states or 7 states all put together, I want to conduct the load flow analysis. Therefore, it is huge task. It is very complex. And therefore, if you do a conventional method, for example, this is about we are talking about transmission system. Therefore, if you want to do the load flow analysis, it will take few minutes. It will take because our power system is dynamic. Therefore, by the time our conditions will changes. Therefore, whenever you want to go very fast and accurate methods, we will go for the artificial intelligence method like neural network, okay, fuzzy logic, as well as the deep learning, machine learning, etc. and all that. Therefore, the basic important thing is that the thing what I will ask in the class is that when you want to go to the artificial intelligence, Whenever you want fast and accurate, then you can go for the AI. Otherwise, we don't want any fastness. There is no need to go for the artificial intelligence. Then, if take most of the time, whatever we will do in the undergraduate students, that is, we will do Gauss method, Gaussian method, Newton-Raphson method, once again the Newton-Raphson polar, as well as the rectangular form, etc. Okay, next. Therefore, this 5 regions. Okay, next. Next. Okay, if you see this figure, energy architecture of the energy management systems or load dispatch center, it is going from top to bottom to top. That is, RTUs are there. From RTUs, they will collect the data. Okay, from because RTUs means remote thermal unit. Okay, it's like a measurement. Therefore, we will keep RTUs in substations and generating station. Important, not all. And communicate, because the data will acquire analog, will convert to digital, and so we are having communication channel is there. Whatever communication you will use, there are several communication. Your mobile is also communication. Satellite communication is there. Out of all communication, fastest, that is less delay, which is there, is the fiber optic communication. As in today, most of the applications will use fiber optic communication. Therefore, from the RTU, the data is going to the state load dispatch center, or we will call area control center. From there, it is going to the regional control center. From regional control center, once again through communication channel, it is going to the national control center, which is at Delhi. Next. Therefore, as I was mentioning, the functions which are done in the load dispatch center, as it may be state load dispatch center or regional load dispatch center, that is supervisory control and data acquisition functions, system monitoring and alarm functions, state estimation, online load flow, economic load dispatch, optimal power flow, security monitoring and control, automatic generation control, unit commitment, okay, and load forecasting, etc. These are all power system functions. Next. Therefore, if you see the blackouts, because I want to talk about the blackouts which took place in 2012 in India. Therefore, there are several reasons are there for the blackouts. Okay, there are some primary causes and secondary causes are there. The reason was because of under frequency. If you see in the third column, which is first one, under frequency is there. The frequency will reduces whenever we are having generation is less than the demand plus losses. Therefore, we can see what happens in 2012 July. Next one. Okay, if you see these grid disturbances, there was a major grid disturbance on northern region at morning, okay, 2:33 hours on 30th July 2012, and northern regional grid, because whatever the states are the northern region we have seen, at the time the load was carrying about 36,000 megawatts, and same disturbance took place on 31st also. Therefore, 31st grid disturbance on 1 o'clock, 13 hours, 31/7/2012, resulted collapse of northern, eastern, northeastern region. Now, on 30th, it is only northern region. On 31st, 3 regions, that is northern, eastern, and northeastern region. The total load at the time it was carrying 48,000 megawatts. Next. Okay, next. Okay, therefore, when grid has collapsed, few hours, that is 5 hours, 8 hours, and 2 hours in northern, eastern, and northeast regions, respectively, there was no power at all because of the entire grid has collapsed. Next. Therefore, in 2012, if you see, as I mentioned, we are in 5 regions. Yes, southern region is not there. That is at the time, the northern region, western region, and northeastern region, and eastern region. The 4 regions are also only connected synchronously. Whereas at the time, southern region was not connected. But southern region was connected by means of asynchronously. Asynchronously means by means of HVDC transmission, southern region also connected. But by means of AC, it is not connected. The southern region did not have any effect on 30th July and 31st July. There is no effect on the grid collapse. Therefore, these 4 regions are affecting. Next one. Therefore, if you see this figure, when we are having this north, east, west, northeastern, these 4 together, and we are calling it the new grid because N is the north, east, west, northeast, all are coming. Therefore, instead of every time 4 grids, I can call as new grid, connected synchronously, thus maintains same frequency. Where SR, southern region, connected asynchronously with the new grid through HVDC links. Therefore, it is not connected synchronously by means of AC, but northeastern region and all that it is we are getting from through HVDC. We are getting the power. And one more thing, you see, the outages on July 31st were of northern region, eastern region, and northeastern region reportedly. Therefore, blackout affected some 700 million people. Therefore, when 700 million people without power, a few hours, therefore it is a large blackout. Next. If we see this figure on July 31st, what happened? The frequency versus time. That is, the frequency, if you see on 31st July, at 1 o'clock, the grid has collapsed. It is nearing to the 48 hertz. That is, if you see we should be 50.2 and 49.5. But on 30th July, the frequency has dipped to, at 1 o'clock in particular, nearly 48. There, in between few hours, there is no power at all. Few hours. Okay. Next. Okay. If you see this, some of the states, how on 31st July 2012, what happened is that if you see this green indicates because even though regionally they are connected in northern region, therefore that the green indicates how much power they are supposed to draw. The red indicates how much the power they are drawing. Therefore, if you see this figure, they are supposed to draw around some 4,300 megawatts. But at 1 o'clock when grid has collapsed, they are drawing more than that. That is, if you see the legend, green is the schedule and red is the how much power they are drawing. Next. Delhi, if you see, they are supposed to draw around 3,000 megawatts. But at 1 o'clock on 31st July 2012, they are drawing less than the required. Next. If you see the Himachal Pradesh, a small state, they are supposed to draw around some 160 megawatts of power. They are drawing less than the required. Less than, no issue. Next. We see the Haryana. This green indicates they are supposed to draw around some 2,400 megawatts, but grid has collapsed at 1 o'clock on 31st July. They are drawing more than 3,500 megawatts. Supposed to draw 2,400, but they are drawing more than 3,500 megawatts. Next. Uttar Pradesh. Uttar Pradesh is supposed to draw around 2,500 megawatts at 1 o'clock. Okay, they are drawing more than the required power. Next. Jammu Kashmir. Once again, Jammu Kashmir is supposed to draw around some 550 megawatts, the green, okay? But at 1 o'clock, they are drawing around more than 600 megawatts. Next. Rajasthan. Rajasthan is supposed to draw around some 1,400 megawatts, but at 1 o'clock when grid has collapsed, they are drawing 2,500 megawatts, nearly double. Next. Chandigarh. Chandigarh supposed to draw around some 300 megawatts, but they are drawing at 1 o'clock. If you come see less than 300, supposed to draw 300 megawatts, less than that they are drawing. Next. Uttaranchal. Okay. Once again, Uttaranchal, as you will know, very small state. They are supposed to draw around some 270 megawatts, but at 1 o'clock they are drawing more than 600 megawatts. They are drawing. Next. Therefore, out of this one, when some states are drawing more power, once states are drawing less power, therefore, resulted what happened is that when generation is become less than demand plus losses. When generation is become, because what you have studied in generally in the load flow analysis, when generation is become less than demand plus losses, so it crosses the threshold, my frequency has gone to nearly 48 hertz. When frequency has gone to 48 hertz, entire grid has collapsed. Therefore, then what government of India in 2012, what happened is that they constituted a committee, okay? Therefore, the committee found some, what are the reasons for that one? Okay, if you see some of the factors that lead to the initiation of the grid disturbance on 30th and 31st, both the days, the same issues were there. Then if you see on 30th July, weak inter-regional corridors due to multiple outages because several regions has collapsed. Therefore, what happens is that the multiple outages took place. That is one more thing is that if you see 400 kV Bina Gwalior Agra, it is a double circuit line. Already one circuit is out because as you will know, when double circuit line is there, when both the circuits are healthy, power will transfer each circuit 50%, 50-50. But when disturbance has occurred, one line is stripped, means 100% will transfer by only single sector, single line. Therefore, that is already occurred. And one more thing is that if you see the high loading on 400 kV Bina Gwalior Agra link, that is the overdrawals by some northern region utilities utilizing unscheduled interchange contributed to high loading on this tie line. Therefore, the most of the time, as you have seen, some states are drawing more power, some states are drawing less power. Therefore, the states which are drawing more power, they are under this circuit. That is, for like Bina Gwalior Agra. Therefore, it is heavily loaded. Next. Therefore, if you see, and one more thing is that because state load dispatch centers are there, they can control by using their SCADA system. But regional load dispatch centers which are there, they will also have the SCADA system and all that they can control, they can switch on or switch off, but still they are not using that authority. Therefore, most of the time what people will do is that regional load dispatch center and orally they will inform. Okay, by telephonic calls they will inform, you reduce your load like that. Therefore, if you see the third point, inadequate response of state load dispatch centers to the instructions of regional load dispatch centers to reduce overdrawals by northern region. Therefore, in the northern region, they are saying when the states which are drawing more power, they are orally informing you reduce your load. Most of the time, when sufficient generation is not there, what people will do? To maintain frequency constant, they switch off the loads, particular areas for some time. Therefore, even though the regional load dispatch center people are saying to the state load dispatch center, reduce the overdrawal, but no one is listening. And fourth point, if you see, the loss of 400 kV Bina Gwalior link, in that one also, we are having, in the protection point of view also, if you see the distance protection, will have the zone 1, zone 2, zone 3 protection. And because of the overloaded, zone 3 protection, okay, it is mal-operation took place. This is also one of the reason. Next. Therefore, next, either on 30th or 31st, the reasons are same. Therefore, the committee, which was constituted by the government of India, they took some decisions. Next. Okay. Therefore, what the committee has suggested is that is measures that could have saved the system from collapse. Okay. The committee has given recommendations because if you see, in an emergency system operation condition, such as on 30th and 31st July 2012, even some of the corrective measures out of the list given below might have saved the system from collapse. Therefore, the recommendations given by this one is that we should have the first point, we should have the better coordination from states as well as the regional grids. And second point is that because when states are overdrawing more power, they short circuit the governor. Governor is the heart of the load frequency control. To maintain the frequency means constant, we should have the governor should come into picture. Therefore, at the time, what electricity board people, what they have done is the respective state, they disconnected the governor. Therefore, now the committee says activation mandatory of primary frequency response of governors, that is the governor's automatic response to adjust output with variation in the frequency. Next. Okay, yeah, keep it. No, back. Okay. Therefore, in this one, and one more thing, if you see, as on today, we have the frequency system is under frequency is the reliable trip. Okay. But apart from the under frequency shedding, under frequency measurement, we should have the df by dt based load shedding also should be required. The committee suggested. Then how will you get the rate of change of frequency? What is the advantage of the operator? Therefore, frequency is reducing, but how fast my frequency is reducing, we require some other equipment. Therefore, as I'm to measure frequency and voltage, current with respect to time, then and rate of change of frequency, they suggested some PMU, phasor measurement unit, or we will call synchrophasors. Okay. Therefore, I will talk about the synchrophasor in continuation at the end. Therefore, this dynamic security, because most of the time we will do in the load dispatch centers or energy management system, static security assessment. Therefore, the committee suggested it is better to go for the dynamic security assessment because every time my power system is dynamic, therefore every time what is happening, what is the voltage, what is the current, what is like that to take care of, we should conduct security analysis. dynamic security analysis. Static security will be there and dynamic security. The committee is suggesting to conduct every time we should do dynamic security analysis. And one more thing is that the fifth point, adequate reactive compensation, specifically dynamic compensation. Therefore, most of the time in power system, real power and reactive power, therefore, what the reactive power is nothing but your voltage magnitude. Therefore, committee is suggesting you should have dynamic compensation. For example, as in today we are having shunt capacitors are there. There is a shunt capacitors, we are having the breaker because as I mentioned, by using sitting at low display center, I can switch on the shunt capacitor. But there is a static compensation. But what is the dynamic compensation? The dynamic compensation is nothing but your fax controllers. Wherever we are having thyristors are there, the switches, thyristor is acting as a switch. Therefore, we switch on, it fast compensation will takes place. That is we will call as a flexible fax controllers, flexible AC transmission system. We will have the SVC, static war system, TCSC, thyristor control series compensation, okay, StatCom, okay, SQC, etc. Several things are there. Therefore, the committee suggested we are having dynamic compensation in place of static compensation. And one more thing is that better regulation to limit overdrawal and underdrawal, that is unscheduled interchange mechanism, specifically under insecure operation system. Therefore, we should have the regulation how to control overdrawal and underdrawals and all that. And the seventh point, measures to avoid mal-operation protective release, because the grid which has mal-operation due to frequency has reduced, okay? And apart from that one, the third zone, distance release is also mal-operated. Next point, next PPT. In this one, if you see, the most important suggestion by the committee is that deployment of adequate synchrophasers based wide area monitoring system and system protection system. Therefore, what committee suggested is that as of today, in place of SCADA system, okay, it is better to have a synchrophaser or PMU, both are same. Therefore, here most of the time when you are having this some data, one data to another data, some time delay will be there. But whenever you are having a synchrophaser is there, all measurements will come with respect to certain time. Therefore, that's why we will call a synchrophaser or phasor measurement unit. Therefore, by using PMUs, we can monitor, we can protection, we can do everything. Therefore, and if you see, assume the black box, PM is a black box, input is the voltage and current. What output we will get is that voltage, magnitude, and phase angle. Current, magnitude, and phase angle. Apart from that one, frequency, df by dt, rate of change of frequency. These four parameters you will get from the synchrophaser or phasor measurement unit. Next. Okay. Therefore, okay, next. In this one, based upon this one, it comes under the thing is that some smart grid. Okay. The smart grid, as you will know, this what do you mean by smart? Anyone can tell? Every time we are using the word smart. What is a smart? The smart is nothing but automation or intelligent thing. Suppose if you see, for example, in this one, okay, so smart means, once again I'm repeating, it is automation or it can be intelligent decisions it will take. Grid, as you will know, which are all generation which is connected at particular point, we will assume that we will call as a grid. Therefore, to go for the smart grid, what are the drivers? What made us to go for the smart grid? Because in the smart grid, several things will come into picture, the smart meter, etc. Therefore, in this one, what are drivers? The drivers for the smart grid, the requirement for the smart grid is that increasing demand, because every time when demand is increasing, what we are doing is that we are starting generating stations. And second point, high aggregate technical and non-technical losses and aging of assets, old generators, transformers and feeders, and grid to carry more power, okay, because demand is increasing, energy mix, because we should have the need for renewable sources, and billing and collection. Okay, next. Hello. Okay. Integrate, isolate technologies, that is smart grid enables better energy management and better power quality and practice management of electrical network during emergency situation. Therefore, these are some of the drivers requirement for the smart grid. Therefore, Government of India, what it has done is that they started some smart grids. Okay, benchmark. Those I will talk. Therefore, for example, they get Pondicherry. Therefore, to discuss or to test how the smart grid will work, we should require the basic first building block is the smart meter. What is smart meter? Before getting smart meter, if you see in our houses also, our residences, good old days were having electromagnetic energy meter. That is, a disk is there, disk used to rotate. How many based upon the revolution per minute, okay, RPM of the electromagnetic energy meter, then we should use to check how many units we have consumed. As in today, there is no electromagnetic energy meter. All the residences, industries, everywhere, it is replaced by means of the electronic energy meter. Then what is the advantage we are getting electronic energy meter? When we are having this electronic energy meter, apart from the number of units you are generated, what is the power factor? What is the maximum demand? 5 to 6 measurements you will get. Okay, if your free time is there, just stand before the electronic energy meter and check what measurements we are getting. Therefore, whenever we are having this, a smart meter is installed in our houses, it will take down the line another 5 to 10 years. Okay, smart meters are replaced. Okay, electronic energy meter replaced with smart energy meters. Therefore, what is the requirement? The requirement is a basic two-way communication is required. We require in smart grid is nothing but it will have power systems, power electronics, IT, information technology, and two-way communication. As of today, we are having only one-way communication from substation to the our residences. But whenever two-way communication is there, substation to the residences, from residence to substation which is there, then substation people, okay, then they can find out each house number one, how much power they are consuming, how many ACs they are switched on, how many geysers they are switched on. Therefore, if generation is less, they can switch, sitting at load dispatch center in the smart grid, they can switch off from there itself. As of today, no one cannot. If I switch on my 10 ACs, no one cannot switch off. Therefore, whenever we are having the grid becomes smart, then from the substation itself, they can switch off our ACs. Some of the extra power consuming devices. Next. Therefore, the smart grid we will call with different names, that is smart electric grid, smart power grid, intelligent grid, IntelliGrid, and future grid. Therefore, most of the time we can call it the intelligent grid, or because it will take own decisions and all that advantage I will talk. Okay, or future grid. Future means we don't know how much time it will take. Okay, next. If you see the definition, a smart grid is an electricity network that can intelligently integrate the actions of all users connected to it. Generators, consumers, and those that do both in order to efficiently deliver sustainable, economic, and secure electricity supplies. Therefore, whenever it is doing all these functions, we will call that grid as a smart grid or intelligent grid or future grid. Next. Okay, as I was mentioning, it consisting of power systems, power electronics, communication, that too, a two-way communication and information technology. These four put together we will call as a smart grid. Okay. Therefore, good old days, communication used to study by only communication people, ECE, but as in today, electricity, our triple E students or triple E engineers also should know what is the communication. Okay, next. The smart grid will be characterized by a two-way flow of electricity and information to create an automated, widely distributed energy delivery network. Okay, next. Okay, the attributes. Okay, attributes of smart grid is advantages are that self-healing. What do you mean self-healing? The self-healing is nothing but suppose most of the time, as in today, what people will do is that power protection will use reclosures. Suppose in the forest areas, night time when tree branch has fell down between two conductors, when a tree branch that is with the wet condition is fell between two conductors, then it will become short circuit. Then what happens is that only normal circuit breaker is that power is off. Therefore, the night time the electricity board crew cannot come into the forest. Therefore, until morning there will not be any power. Therefore, good old days what they have done is that they replaced with another circuit breaker which is having, okay, that is we will call reclosure. That is, the reclosure is nothing but a study, that is, it will have designed 3 times, okay, or 4 times based upon the design, on, off, on, off, on, off. That is, it will do 3 cycles or 4 cycles. That is, if the branch just fell down between two conductors, if you switch on the breaker, what happens? It will burn at the ends of the tree branch. Like that, if you do 2 times, 3 times, or 4 times, then the ends will become short. The automatically the branch will fall down. That is the objective of the reclosure. Okay. Therefore, it is the permanent fault is there. For example, chain is there between two conductors, but it will not. Reclosure cannot clear that fault. Okay, we are talking. That's why most of the time the reclosures are used in the forest areas. Therefore, whenever if you are having the small grid or future grid which is there, it is self-healing. Suppose a fault is occurred, then what? It is an intelligent grid, okay, small grid. That is, therefore, if fault is occurred, what it will do? It will disconnect the faulty section, and whichever healthy section is there, it will connect automatically. It will become like island. Then I will get the power, because few houses will not have any power, but remaining houses will get the power. That is what you will call it is self-healing. That is power disturbance events. And one more thing is that it enables active participation by consumers in demand response. Therefore, whenever we are having as demand response which is there, a consumer also become a part of the to generate the power and all that. If you switch off the power or switch on the power based upon the requirement, okay, is also becoming a part of that one. And one more thing is that it operates, because it is an intelligent system, it operates resiliently against both physical and cyber attacks. Because as you will know, every time some cyber attacks are taking place and physical attacks are taking place. Therefore, physical attacks are there. It is self-healing is the point is very, very important. It is coming into picture. Cyber attacks also then we can overcome by means of intelligent grid. And it provides good quality of the power, and it accommodates all generation and storage options, including plug-in vehicles, because we have generation, storage, and all that. And one more thing, as in today we are talking electric vehicles, okay. Therefore, in this electric vehicles, that is plug-in vehicles. The plug-in vehicles means how it will act as a source to the grid, because vehicle to grid or grid to vehicle, vice versa. Therefore, when vehicle to grid means, suppose it example for when we are having a airport where a particular flight is coming, hundreds of vehicles, sometimes thousands of vehicles are waiting, and nearby when we are having a plug is there, all the vehicles are plugged in, okay, then it is pumped into the grid. That is what we will call vehicle to grid. And as you know, whenever deficiency of the power is the battery, we want to charge, then we will take from grid to vehicle. Next. And it enables new products, services, and markets. Therefore, as you have seen, the new product with the new name, what I was mentioning, synchrophaser or phasor measurement unit, okay, we can use in the transmission system as well as a distribution system. The cost of the synchrophaser or PMU, phasor measurement unit, in transmission system, it costs around 5 to 6 lakhs, whereas in case of the distribution system, you will call the micro PMU, the cost is around 1 lakh, like that. And it optimizes asset utilization and operating efficiency. Next. 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 Okay. Next. Okay. Okay. Yeah. Just. Okay. In this one, if you see the evolution of the power system from static to dynamic structure, if you see from central generation and control, because if you see the good old days, we used to call, suppose if you take APSCB, United Andhra Pradesh, which is there, Andhra Pradesh State Electricity Board. Uttar Pradesh is there, Uttar Pradesh State Electricity Board, West Bengal State Electricity Board. If you see, as in today, we doesn't have like electricity boards. We're calling generation company, that is Genco, transmission company, Transco, and distribution company, Discoms. Therefore, we have moved from a central generating station. We are having is a vertical structure like generation, transmission, distribution, consumers, etc. But from there, from vertical system, we are coming to horizontal system. What happened here? When we are having generation company is different, transmission company is different, distribution company is different. And one more thing is that when we are having these renewable sources, we are having microgrid, we are calling. Therefore, from central generation to we are moving from central and distributed generation with intelligence. Okay, everything is intelligence, that is digital. And one more thing is that if you see from load flow following Kirchhoff's laws, that means now it is not following Kirchhoff's laws, because at the time when we are having only source and sink, but here as in today what we are having, power is coming from two sources also. One is the from grid, another from the microgrid also will come. Therefore, load flow control by means of power electronics. And power generation according to load demand, because the load is increasing means, as I mentioned, generation also we have to increase. We have to start some thermal station or nuclear station, etc. But as on today, what we require, we are starting with renewable sources. That is controllable generation, that is variable in feed and demand in equilibrium. Next. And here if you see, manual switching and trouble response in good olden days, as in today we are having automatic response. Okay, we want to, as we have seen, self-healing, etc., and all that, automatic response and predictive avoidance. And most of the time, suppose if we see for the maintenance, we will say after 3 months we should get the maintenance, or 6 months. But as in today, because of intelligent techniques, okay, when we are having artificial intelligence techniques, we are using, that is predictive, because I can predict whether as in today my generator is required some maintenance or not. That is we will call predictive maintenance or predictive avoidance. And if you see the fifth point, next backpack, deterministic response of power flow. Okay, deterministic. Okay, exact. Okay, generation, transfer, etc. is there. But as in today, we are having monitored overload of bottlenecks, and it is a predictive maintenance. It is prioritized condition. Okay, next. Okay. If you see these grids, okay, smart grid compared with the existing grid, what we are having is that existing grid we are having electromechanical, here intelligent grid or smart grid, digital, and one-way communication, and we are having two-way communication is there. And centralized generation only one point, but here distributed generation because of this renewable sources, what we are in distributed generation. It is hierarchical, there is generation, transfer, transmission, distribution, etc. Only few sensors are there, and it is a blind. Blind means when it's faulty circuit, it will not take any decision. And manual restoration, person should come and restore, and failures and blackouts. But in case of intelligent grid, throughout the network, we will have the sensors and self-healing or self-monitoring. It will monitor itself. It will take own decisions. That is self-healing, and adaptive and aligning. What is adaptive? Adaptive means it will take its own decisions. Adaptive control. Because if you see the PID control, I'm giving simple example. Adaptive. Whenever we are having PID controllers are there, when we will design or when we will determine the value of proportional controller, integral controller, derivative control gains which are there, they are valid only for a particular operating conditions. Whenever the operating conditions are changed, but that is my real power is changed, the reactive power is changed, then the settings KP, KI, KD, they will not work. Whereas if you use in place of a neural network controller, fuzzy controller, okay, these artificial AI controllers if you use, then there is no need to tune. Automatically it will changes. Next. Therefore, in the good old days, we are having manual check. Here we are having a remote check. Okay, limited control and pervasive control. Pervasive control means throughout the system, we are having the controllers. Suppose we are having our house, we are having PV system is there. Therefore, in our house also we can have the control system. Therefore, with the limited control throughout the system control, the pervasive control, and few customer choices. Here many customer choices. And here one more thing with respect to, sometimes you will call customer, sometimes you will call consumer. Any difference is there between customer and consumer? Anyone can tell? The consumer is nothing but it doesn't have any choice. As on today, it doesn't. Suppose I am not getting the power and my power quality is not good, I cannot change. Suppose like a SIM. Okay, if you're not, your Geo is not good, you can go to Airtel. Airtel is not good, I will go to some other. You're having your choice. But as in today, in India at least, we doesn't have any choice. That's why we are consumers. Well, then what is the customer? Customer is that is having some choice. If you go, suppose I will go to a market to purchase my shirt, okay, then I can move several shops. Then I can purchase from a particular, which is less cost and quality of my shirt is good. Therefore, electricity point of view also, when you are having the choice You are the customer. When you doesn't have any choice, you are the consumer. Next. Next. Hello? And as I'm mentioning, this SCADA and PMU, phasor measurement unit, okay, the SCADA is the heart of the load dispatch center. We will have the in the distribution system also. We will have the subload. We will have the SCADA system will be there. If you see the PMU and SCADA system measurement, SCADA is the analog, PMU is the digital, and resolutions point of view. If you see the SCADA is very slow. It measures only 2 to 4 measurements or 2 to 4 samples per cycle. Per cycle means how many minutes? 20 milliseconds, isn't it? Because India, we are having 50 hertz frequency is there. Therefore, it measures only 2 to 4 samples per cycle. Whereas in case PMU, it measures 60 samples based upon the hardware. It measures 60 samples per cycle. Observability is it is a steady state, whereas in case of PMU, it is dynamic in nature. Monitoring point of view, local area. Local area means small area, whereas the PMU wide area it can measure. And one more important feature is that the SCADA it cannot measure angle. Voltage is measuring magnitude, but angle it cannot measure. Current it will measure, but current angle we should have a separate system. We should have. But in case of the PMU, it measures voltage as well as the angle, current as well as the angle. It measures. This is the fifth point is very, very important with respect to the SCADA system as well as the PMU system. Next. Okay, next. Okay, if you see the components of the smart grid is that we require the building blocks. That is what it will do is that metering automation, that is smart metering, advanced metering infrastructure. The advanced metering infrastructure means it can be meter, that it can be a PMU, it can be IAD, intelligent electronic device, or it can be micro PMU. Okay, apart from the meter, it requires some wires, etc. What we will call advanced metering infrastructure. The wording AMI is very frequent, very frequent. We will use in the smart grid. And substation automation, distribution automation, transmission automation, and renewable integration, okay, and demand participation, energy storage, energy efficiency, and system operation. These are all things we can do. These are some of the components of the smart grid. Next. Okay, as we're talking about our topic itself, this is AI application to renewable sources. Therefore, in the microgrid, as you will know, the dispatchable generation is the fuel cells, micro turbines, IC engines, as well as the intermittent generation, that is wind turbine, because weather based on weather condition, and solar, photovoltaic, and storage is batteries, ultra capacitors, electric vehicles, etc. Next. Okay, back. In India, we're having when smart grid is there, we're having still stabilize the smart grid. Therefore, Indian smart grid consisting of 7 working groups. There are 7 working groups. What they are doing is that working group 1, they're looking after advanced transmission. That means they will talk about standardization of PMUs, phasor measurement unit, VAMs, wide area monitoring system, VAMs, and FACTS, flexible AC transmission system, etc. Whereas in case of the working group 2, they will take care of advanced distribution, that is SCADA, distributed management system, substation, automation, self-healing, distributed generation, power electronics, etc. by means of working group 2. Next. Working group 3, communication, because communication is a very, very important part in the smart grid. Therefore, two-way communication is required. And working group 4, that looking after metering, as in today several smart meters are available, the cost is more. Therefore, to reduce the cost, what to do? That working group 4 is looking after. And working group 5, that taking care of consumption and load control, that is demand response, home automation, appliances, storage, vehicles, etc. And working group 6, they're taking care of tariff, finance, etc. That is policy, regulation, standardization is required. That working group 6 is taking care of. Next. The working group 7, last one, they taking architecture, how the standard smart grid architecture is required. Therefore, architecture and design is looking after by means of the working group 7. Next. Therefore, to make all the standards, we're having that is National Institute of Standards and Technology, NIST, NIS, not NIT, NIT. NIS, National Institute of Standards and Technology, is taking care of. Therefore, smart grid conceptual model provides a high-level framework for the smart grid that defines 7 important domains. What are the domains? Generation, transmission, distribution, customers. Good old days, customers were not there. But here, customers also one of the part in smart grid, operations, markets, and service providers. These 7 domains is taken care of by this NIST, National Institute of Standards and Technology. Okay, next. Therefore, just back. Yeah, next. What is that? Oh, next. Okay, next. Oh, next. Okay. Yeah. This, if you see the smart grid conceptual model in this one, if you see, we're having bulk generation, transmission, distribution, and customer. Good old days, we're having generation, transmission, distribution, but we're having 4 customers also coming to picture. It is moving from bulk generation to transmission to bulk generation, like that we can go by direction. And one more thing is that from bulk generation we go to markets, because we're having powers from deregulation. Okay, market. Okay, power generation also is like a market. If you go to a market, I can go purchase my vegetables from vendor 1, vendor 2, vendor whatever we want. Like that, power also, power market is there. I can purchase power from generation company 1, generation company 2, etc. Therefore, markets is going to operations to the service provider, or you can markets directly to go to the service provider. This is about the smart grid conceptual model, how it looks like. Next. Okay, in this one, if you see back. Yeah, this is, if you see, in the bulk generation, we're having renewable, variable. The important is see, renewable, non-variable. Because the renewable variable means based upon the weather conditions, my power generation will vary. Therefore, solar and wind will come under renewable variable. Whereas in case the renewable non-variable is that your hydro, biomass, geothermal, pumped storage. Pumped storage and hydro both are same. As you will know, pumped storage will reserve after the water. Therefore, these are all renewable but non-variable. Whereas wind and solar will come as renewable variable. And remaining conventional thing, nuclear, coal, and gas will come as non-renewable, non-variable. Okay, next. Okay, next. Okay, we can move fast. Okay, in this one, yeah, customer, yeah, back. Distribution point of view, if you see, when we are having this, if you see this internal part, distributed storage and distributed generation, okay, that is solar, wind, etc., and all that, and sectionalizers, etc. And remaining thing we are having transmission, operation, and markets. Next. Yeah, next. Okay, just back up. Back. Okay. Yeah. If you see the synchrophaser technology, we are talking about Indian blackouts. If you see, the blackouts are not new, because India 2012 took place, but in USA 1990 August 1996 the blackouts took place, and northeastern blackouts August 2003. India blackouts on 30th and 31st July 2012. There are some of the blackouts, the major blackouts. Okay, next. Therefore, in this one, the continuous load growth expected with different generation mix. Therefore, not only we should not only conventional source. It is not possible, as you will know. Therefore, we should generation mix, and the SCADA system is not suitable for real-time control. What do you mean real-time control? The real-time control is nothing but, as I mentioned, when RTUs are there, they will collect the data, convert analog to digital, then communication channel, fiber optic communication channel, they will go to the load dispatch center. The load dispatch center, they will do several applications. There, what they will do is that they will do some, for example, load flow or automatic generation control and all that. Then, so for example, load flow, suppose we first output from the load flow is the voltage, magnitude, and phase angle. If the voltage, magnitude, particular bus is not within the limits, plus or minus 5%, My voltage is only 0.85% per unit. Therefore, how to make it to approximately 1 per unit? That is what, as I mentioned, when you are having nearby shunt capacitors are there, by sitting at load dispatch center, I can switch on the shunt capacitor. Therefore, these things we will call real-time control. Therefore, the SCADA system not suitable for real-time control or time-critical applications. Why? Because the SCADA is an analog device. Therefore, the one measurement to another measurement capturing some delay will be there. As in today, even though some delay is there from one measurement to another measurement, we are not considering. Therefore, we require the PMU, phasor measurement unit. Okay. Fourth point, if you see back, need for advanced real-time monitoring tool. Therefore, every time I want to get real-time is online with respect to some time. Okay, and need for wide area control and recent smart grid initiative. Therefore, to have all these things, we need the SCADA system. We need PM, phasor measurement unit, or synchro phasor. Next. Okay, in this PMU, the phasor technology, if you see, okay, it is consisting of phasor measurement. The name itself, phasor measurement unit, PM. The phasor means magnitude, phase angle, both will be there. Consisting of phasor measurement units, that is, and PMU is one thing, PDC is there, one more thing, phasor data concentrator. Higher level, PMU is lower level, PDC is the higher level, it captures more data. Okay, that we'll call phasor data concentrator. And sources of synchronous generation, because to have all these things we require a GPS also. And in this one, it is manufactured or first fabricated in the Virginia technology, USA. Okay, and it is the Indian who has manufactured this first PMU is the Indian, that is Padke. His name is Padke. Therefore, some standards are there, some IEEE standard, C37.118, etc. and all. Next. Therefore, in this, if you see this phasor measurements, that is synchro phasor measurement technology is used extensively at transmission level for system monitoring. And synchro phasor is a method for measuring and determining adequate phase relationship between phase quantities at different locations on power systems. Okay. Next. Next. Okay. Next. Okay, the PM, if you take input is the voltage and current, output is the with respect to time, we'll get the magnitude and angle of the respect to voltage and current, frequency and rate of change of frequency. Next. Next. Skip now. We'll go. Yeah, just this one will be there. Back. Just I will talk about this back. Yeah. These are some of the smart grid pilot projects in power distribution sector. That is, we're having in India, we're having 14 benchmark projects are there in Karnataka, United Andhra Pradesh, Assam, Gujarat, Maharashtra, Haryana, Tripura, okay, Himachal Pradesh, Pondicherry, Rajasthan, Chhattisgarh, Punjab, Kerala, and West Bengal. In this one, if you see, suppose if you take Andhra Pradesh, second point, okay, to have the smart grid project, therefore, at 11,904, they kept some point, that is GD metal area. At 11,904 consumers, they installed smart meters. And what they are doing, AMIR. AMIR means Advanced Metering Infrastructure, Residence, AMIR, Advanced Metering Infrastructure, Industry, etc. These things. AMIR, Advanced Metering Infrastructure for Residential Consumers, AMI, Advanced Metering Infrastructure for Industrial Consumers, OM, Outage Management, PLM, Peak Load Management, PQM, Power Quality Management, MG, Microgrid, DG, Distributed Generation. Therefore, each benchmark project, they are using different functions. Next. Okay, this is about the PMU. Next, we'll go to the next. Oh, yeah, just back. PDC, just I want to show. Back. Yeah. In this one, as I mentioned, back. Next. Yeah. When we're having this PMU, PDC, the PDC, there's a data concentrator. It will carry, as in today, 6 PMUs. Data it can collect. It can store up to 6 months. Therefore, from the data, it can do some, in the load dispatch center, what the functions they are doing, it will do some advanced application software. Therefore, it can do system control, protection functions, etc. etc. Next. Next. Okay. Next. 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 Yeah, just back. Okay, some of the PMU vendors are some ABB, Siemens, GE, SCL, Areva, etc. Some of the vendors of the manufacturers of PMU. Next. Okay, next. Yes. Yeah, next. Yeah. In this one, when you are having all PMUs and PDs are there, substation, you will keep some PMUs. PMUs data will go to the PDC. PDC will go to super PDC. Like that, we can do different functions in the control center. Next. 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 Just back. Just wait. Just. Yeah. In this one, in the research areas, if you see in the smart grid, wide area active control, adaptive protection control, network management and devices, real-time network simulation, advanced sensors and measurements, distributed pervasive communication, and knowledge extraction by intelligent methods. Okay, that is AI methods, novel design of transmission and distribution system. These are some of the research areas in the smart grid. Next. Now come back. Most of the time in the smart grid, when we are having PMUs and all that, we will get lot of data. Therefore, as of today, the algorithms, what we are calling data-driven algorithms, as well as the model-driven algorithms. Whenever you are using the word data-driven technologies, means it's like machine learning, AI, neural network, for deep learning, etc. Whereas the model-driven algorithms are nothing but, suppose whatever we are doing conventional way, suppose I want model generator, model transmission line. That is a model-based algorithms. Therefore, that we are distinguishing data-driven algorithms and model-driven algorithms. Therefore, whenever a data-driven algorithm is there to train the network, okay, we require a lot of data. Therefore, data-driven is the use of data to guide action and policy. Using data to automate work, including decisions. Based upon the data, we will take the decisions. Therefore, in the data-driven algorithms like artificial intelligence, therefore, more data, what I will say, more data, more accurate. Less data, less accurate. Therefore, large data is required. And one more thing is that this data analytics are playing an important role in the modern industrial system. Therefore, everywhere we are having, okay, data-driven algorithms are there. That is artificial intelligence, that is neural network, data, deep learning, etc. Next. Okay. Back. Okay. ముందుకు వచ్చేసాను. Next. Okay. If you see when large data is that, what we call the big data characteristic in small grid is that 5 V's we will use. One is the volume, velocity, variety, veracity, and value. Volume means it refers to the vast amount of data generated, and velocity, how fast, okay, refers to the speed at which new data is generated and the speed at which data moves around, and variety refers to types of data we can now use, and veracity refers to trustworthiness of the data. Data should be less noisy. Okay. Value refer to the ability to extract valuable information from the huge amount of data. Therefore, with respect to data, is there 5 characteristics of this data. Next. If you see this back, intelligent data collection devices, that is smart grid, which is there, we will have the intelligent device and technology and application. If you see, one is the AMI, advanced metering infrastructure, another PME, phasor measurement unit, another one what you have seen, wide area monitoring system, another one remote terminal unit, RTU, okay, collects the data, and supervisory control and data acquisition system. There, whatever we have discussed, all these things, we are calling as intelligent data collection devices in smart grid. Next. Therefore, in this one, we're having the communication infrastructure of this one, HAN, home area network. What is the home area network? That is enabling, because in every area house we are having these renewable sources, in particular solar, okay, enabling communication among smart home or office devices and smart meters for local energy management. Okay, we'll call home area network, and several home areas we'll call as the consisting of several house areas for energy consumption, data aggregation, and storage at load center. Okay, and wide area network we'll call as the enabling communication of all small grids components. Next, and in this one, the concepts for the data analysis point of view, we require just back a little bit. Back. ఓకే, ముందుకు వచ్చేయండి, ముందుకు వచ్చేయండి. యా, ఇంకా ముందుకు వెనక్కి వెళ్తున్నారు మీరు, ముందుకు. Okay, therefore, as we are seeing most of the time, suppose if you see there are several things are there that we have seen in the artificial intelligence, the wide thing. In this one, we will talk about neural network, fuzzy logic, deep learning, machine learning, etc. Therefore, as we have seen that Surendra Reddy what he was discussing is that is, suppose if you take a neural network, what neural network is there? Anything, any artificial intelligence thing is that the thing is the two things: training as well as the testing. Therefore, to train the network and test the network, we require large data. Therefore, suppose if you take a neural network, I can train as well as test. Okay, I will train with respect to large. If you take less data, your accuracy suffers. Therefore, large data is required. Then I will get more accuracy point of view. Therefore, in case of neural network and machine learning, what is the basic difference? In case of the neural network, as I mentioned, training and testing. Okay, machine learning also will do, but the most important thing in this machine learning, what it will do is that for the regression analysis. That means what it will do is that it will determine the model. For example, if you see when elections are there, what in TV channels they will see, they predicted some X party will win or Y party will win, whatever it may be, based upon artificial intelligence. Then how they will capture the data? They will survey from 18 years to 18 years to 25 years. They will take their opinion from 25 years to 40 years, 40 years to 50 years. Okay, 50 to 60 like that, 60 to 70 like that. Therefore, after getting all the data, they will devise into a model. What model? A straight line model or straight line or non-straight line. That is quadratic equation. Then from that one, suppose if you see in this one, next one, next. Therefore, in this one, what they will do is that a model is determined y equal to mx plus c. For example, a linear model. Y is the output, m is the slope, x is the input. Suppose if you generated what is the value of the m, okay, we will several methods are there. We can calculate m from the data. Therefore, when m is there, if you give some input, okay, based upon some opinion, then which party will win? Y I can calculate. Therefore, that is what we are doing. We are building the model. Or suppose quadratic equation is there, ax square plus bx plus c. Therefore, x is the input, y is the output. Therefore, based upon the input, I can get the different outputs I will get. Therefore, that is what we are doing. That model we are generating. That is the difference between the neural networks as well as the machine learning algorithms. There are several algorithms: regression, linear regression, non-linear regression, trees, decision trees, etc. and all that. Okay, next. Okay, in this one, this AI, ML, and data mining which is there, AI is the branch of computer science that aims to program computers to perform tasks in more intelligent and human-like ways using reasoning and decision-making techniques modeled after human intelligence. Therefore, most of the time, as we are talking about that artificial intelligence, we are making like a human-like, okay, machine. Therefore, as in today, you may be knowing that is apart from the electric cars, we are having autonomous cars, that is driverless cars. Whenever you want driverless cars, we require this artificial intelligence techniques. Therefore, they are playing a vital role in Tesla and all that they are manufactured also in I think USA and all that driverless cars also available. Next. 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 Yeah. Okay. In this one, if you see difference between most of the time, this machine learning is nothing but statistics. The mathematicians who are statistics people are good. They can learn easily the machine learning. And whatever you call either machine learning or neural network or deep learning, whatever we are having, my opinion is that one should do with hand calculations. Without hand calculations, everything is fuzzy. That is, after hearing, we'll forget everything. Therefore, when we should work, after working, then if you use some programming like Python or anything, then you will understand 100%. Otherwise, everything is fuzzy only. Okay, these are some of the similarity of this one, what we were talking about in the machine learning and statistics point of view. Next. Okay, the different learning algorithms, okay, of the machine learning is that, as I was mentioning, linear regression, logistic regression, linear discrimination analysis, okay, CART, Navy Bayes, K nearest neighbor, learning vector quantizer, support vector machine, several things. Next. Next. Okay, this I will talk with this one, I will stop. The principle of the machine learning is that the common principle that underlies all supervised machine learning algorithms for predicting and modeling. Mostly we'll use for the predicting, okay? And therefore, in the machine learning, the second point is very, very important. ML algorithms are described as learning a target function f that best maps input variable x to and output variable y. That means, for example, second one, if you want to summarize, when you are having equation y equal to f of x, therefore y is the output, x is the input, f is a function. Therefore, in this machine learning principle, this f I want to calculate. What is the f? F is whether is a linear function or non-linear function, etc. That is the basis for the machine learning algorithm compared with the other deep learning or neural network. Okay, next. Okay, therefore, this is the some multi-objective, etc., and all that will. Okay, this as time is up, before stopping. Okay, I will use one thing before stopping the this type of lectures. When we are having here, we are having several AI applications like neural fuzzy. We can make use of for the renewable sources. Most of the time, as you will know, in the renewable sources, more people use MPPT technique because of weather changing conditions and all that. This may, where I'm conventional POs, okay, perturb and observe. Several methods are available. Conventional methods are available for the MPPT techniques. Apart from this one, as in today we are using neural network based MPPT technique, fuzzy logic based MPPT technique. Okay, and we are having this what is that conventional neural network. Okay, that is convolution neural network based. We are having MPPT techniques. Several techniques are intelligent techniques. Therefore, whenever we are having this intelligent techniques, okay, we can use not only MPPT, several things. Therefore, based upon this one, there is one proverb is there. Just come back. Back. Hello? Back. Last question. Last slide. Move చేయండి ఇంకా move లేదా okay, some that is not there. Okay, some proverb is there. The proverb is that if you're having a hammer in your hand, okay, if you're having a hammer in your hand, everything looks like a nail. That is what is the meaning of this one. When you are having a hammer in your hand, everything looks like a nail. When you are having, suppose our kids, okay, students are coming from the hostel or vacation to the house, what mother will do? She will cook good tasty food and all that. After eating, what that kid will do, what that student will do, he will watch TVs, etc. Suppose he found some hammer is there, just to take the hammer, he will see here and there, and a nail is coming out. Even though there is no nail on the table or on the walls, just he will hammer. Therefore, this is the thing. When you are having a hammer in your hand, everything looks like a nail. Therefore, whenever you are having this AI techniques, if you know, that is neural network, fuzzy logic, deep learning, machine learning algorithms, if you know, then you can able to do how to attack the problems, which is conventional done. Any problem is there, then how we can overcome. Therefore, this is the thing is that when you are having a hammer in your hand, everything looks like a nail. Hammer is nothing but here AI techniques, and nail is nothing but problems to solve. Therefore, all these problems, okay, we can hybridize because if we want to publish a papers and all that, we require hybridization of different algorithms. Then it will become new. Therefore, something is new, the paper will be published. Okay, with this one, I will stop. Anil, thank you very much for giving me this opportunity. Yeah.
So good evening, sir. Good evening, sir.
Yeah, good evening. Yeah.
Sir, what are any strategies to prevent the modern blockouts in the modern power systems? Sir, any strategies? Primitive measures. Sorry, sir. Primitive measures to.
That's why the committee itself it is given. That is the thing is that we require. First basic thing is that to overcome the blackouts, PMUs. Why PMUs? The PMUs compared to the SCADA system, the data is very very slow. One measurement, another measurement, some delay is there. But whenever we use PMU, then all measurements are coming at particular time. There is no delay from one measurement to another measurement. Therefore, if you conduct your load flow analysis or anything, then there is no issue at all. Therefore, real timely I can control. And one more thing is that I'm measuring at the output of the PMU, we are getting the frequency and rate of change of frequency also we are getting. Then whenever they are measuring rate of change of frequency, how fast my frequency goes on decaying, then I can take operator will take certain action. That is, if sufficient generation is not there, for example, then we switch off the load. If the load is switched off, then my frequency will come to the normal position. Suppose when frequency is available, I can borrow the when real power is available, I can borrow the real power also from other neighbors. Therefore, the PMU will do a lot of wonders to avoid this type of blackouts.
Thank you, sir.
Okay, thank you, Umar. Thank you, Neil. Yeah, thank you. Cannot leave, I think so.
Sir, any attendance will be marked. Sir, any attendance?